Good evening. Thanks very much for coming out. It's another session of Cambridge AI. I think this is the fifth that we've done. We've got a fantastic evening of live demos tonight coming up. I'm Mark Rogers from Grounded AI. Grounded AI are actually one of the people we'll be demoing a little bit later. My colleague Nick Morley will be talking, and we have Yunpeng Li from Be Certain, and we have Ushnish Sengupta from Sqwish. I'd just like to thank again our host, Zicky Lim from Mills & Reed, for making this happen. Thank you all for turning up. And I'm going to hand over now to our sponsors, Daniel Bone, our co-organiser, I should say, really, from Robert Walters, for putting this event together. We'll talk a little bit about that, and then we'll get on with the evening. Thanks very much.
Good evening. Thank you very much, Mark. So my name's Daniel Bone. I'm from Robert Walters. If you don't know about us, just a quick background. I won't bore you with too many of the details, but we are a global PLC recruitment business. We cover everything from tech to legal to supply chain to HR. You name it, we will probably be able to help you out. So any questions, please just let me know. Myself personally, I've got over 5 years experience within recruitment within the tech space, and more specifically recently more in the AI and data science world. So my area I cover, London, Oxford, Cambridge. If you're looking for a new role, your friend is, whatever it may be, or you just want to have a chat, that's where I can help you. So I won't reel off all of these, but these are roles that I would typically recruit for. But if you've got anything a little bit funky, then just let me know and I'll see if I can help you, give you my honest opinion. You see there in the bottom corner, we've got Manchester AI, so I've come down from Manchester today, that's where I'm based. My colleague Tom, who's in the back there with his hand up, that's his event, so he runs a very similar event to this, just up in Manchester as well. In terms of events that we've got coming up, obviously we've got Cambridge AI going on in January, little spoiler, January the 23rd. We've got the next Cambridge AI after this one. And also next year, I'm going to be hosting a number of roundtables, so data science and AI leaders, discussing different topics, techniques, whatever it may be. There's going to be a number of them going on as well. So if you're interested in coming along, then just grab me afterwards, and we'll be more than happy to chat. Also, we're looking for more speakers next year. If you want to speak, you know anybody that might want to speak, or you can just recommend somebody, just let us know. We'd be more than happy to have a conversation with yourself or whoever it may be. I'm now going to pass over to Zicky from Mills & Reeve.
Thank you. So good evening, everyone. On behalf of Mills & Reeve, I'd like to extend a very warm welcome to all of you to this Cambridge AI networking event. For those not familiar with Mills & Reeve, we're a 185 partner firm with 1,400 people operating full service in 7 locations across the country, and Cambridge is our largest office. We've got 374 colleagues here in this building. So I'm Zicky Lim, a partner heading up the firm's 16-strong venture capital and investments team. And our lawyers work with a wealth of entrepreneurial and fast-growth businesses, tech and life sciences, on their startups, spin-outs, investment readiness, on their fundraising from pre-seed, seed through to Series A, B, C and beyond, and also their scale-up transactions and ambitions. And we also work with the investors that invest in those sorts of businesses, so the institutional venture capital funds, the corporate venture funds, business angel groups and family offices. And in a typical year, we will advise on between 80 and 90 investments with aggregate values of between 350 million and 450 million pounds. And earlier this year, we were actually really honoured to be awarded the UK Business Angel Association's 2024 Best Legal Team Early Stage Deals. And what that's recognising is not just the immense amount of work that we do in this space, but also our extensive effort in and passion for and commitment to UK early stage investment. So now, the global AI market is expected to grow annually by 37% and is expected to reach 305.9 billion by the end of 2024. It's outstanding. By 2030, AI is estimated to create 133 million new jobs and contribute over $15.7 trillion to the global economy. And countries with the highest AI adoption are really China and India at this stage. And 40% of business leaders report increased productivity through AI automation, whilst, interestingly, 75% of individuals are concerned about job losses due to AI. So it's against this backdrop that events like these are really important to help us share knowledge, educate, and enable people to connect with each other and better understand some of the AI advances and case uses already in progress. And hopefully we can harness AI to do things better, faster, cheaper. Now, before I wrap up my intro, I just want to quickly draw your attention to two initiatives that we've provided to the founders community, and they're free of charge and accessible to everyone. So the first one is our Launchpad app. It's downloadable from the App Store, and it provides information, guidance, and some legal template documents to help entrepreneurs understand the sorts of legal issues that they need to grapple with when they're setting up and growing their new businesses. And the next initiative is our Fast Growth Secrets campaign, and that looks at various aspects and ingredients needed to set up and successfully grow businesses in the UK. And we've done this by basically interviewing various seasoned entrepreneurs and investors to get their comments and thoughts and perspectives on these topics. These are the 4 topics that we've done so far. Please look out for them. If you're a first-time founder, it's all free resource, and we hope you find it useful. Anyway, on that note, I'm going to hand over back to you, Mark.
Thank you very much.
Thank you. Have a good evening.
So I'd just like to introduce our first presenter tonight. This is Ushnish Sengupta from Sqwish AI. And Sqwish AI, I'm going to just introduce Ushnish. He is the founder and CEO of Sqwish, where they are building the efficiency layer for enterprise AI. Ushnish holds a PhD in information engineering from Cambridge, where his research focused on Bayesian machine learning and optimization. He's worked on generative algorithms and published in top machine learning conferences and journals, including NeuroIPS, and developed ML tools for high-stakes applications at Rolls-Royce Aircraft Engines and the German Aerospace Centre. And Ushnish, it's all yours.
Thank you for the introduction. All right. Hi, everyone. I'm Ushnish from Sqwish. We're building the efficiency layer for enterprise AI, so we're building tools to make enterprise AI better, faster, and cheaper, right? And the first product that we're going to launch with is something called a real-time prompt compression API. But before we explain what that is to you, let's look at the problem. Oh, sorry. All right. So, yeah, this graph is probably reminiscent of COVID 2020 times. So this is something that has been happening in the AI space. So context window is basically the amount of information that you can feed to your AI models. And the trend that we see is that the big model providers are now building models which allow you to feed more and more information, like more text, more audio, more video to your AI models, because developers want to build more complicated applications, right? They want to build those agentic workflows. They want to analyze long documents, long conversations. And so this is great, right? This enables more innovation. But so why is that a problem? It's a problem because having very long inputs to your AI models is very bad for latency. So don't be afraid of the word tokens here. A token is approximately a word. It's how an LLM sees its input, right? So it breaks it down into tokens. It's approximately a word. And the more tokens that you have in your input, the longer it takes for the LLM to generate responses, right? So here you see that to produce a response that is only 100 tokens long, if your input is like 100,000 input tokens, so it's like a very long document or something, it takes 25 seconds to come up with a very short response, right? Now imagine if you're like an AI developer building an assistant for lawyers, right? It's going through these long contracts, and your the lawyer, is waiting 25 seconds for a response. They're not going to keep using your app. So that's bad. And so I'm not cherry picking on this poor Llama 3 model here. This is a problem for every single model that's out there. You can see those big black bars. So once you cross a certain threshold, you will see that these models become slower and slower in their response generation speed, right? So that's bad because time is money, but money is also money. And what I mean by that is that the way you pay for AI models as a developer is that you pay per word. So every single word that you feed into the AI models, that costs you money. And last year everybody was happy spending tons of money on generative AI, and that spend is growing. But CIOs and CFOs are now becoming more concerned that, oh, the spend now has to be brought down under control. So there is now more of a focus on efficiency. But you can see this article that said 46% of top executives in companies are now saying that cost of implementation is now becoming more of a concern, and ROI needs to be justified before just plowing in money into Gen AI solutions. So what do we bring to the table? So our solution for apps that are that have these very long inputs and that are slow and expensive is a real-time prompt compression API. So what is that? What does that do? So if you have your very long input, you can send it to our API as a developer, and within hundreds of milliseconds, we will get rid of all the irrelevant or redundant or unnecessary tokens or words that you might have in your input, and we will get rid of all that for you. So that can reduce your input token costs by up to 90%. And it can also speed up your responses by 1.8 times, depending on what size of input you have, right? And it works with every single popular foundation model provider out there, whether it's OpenAI, Anthropic, Claude. We understand how these models break down these inputs, and we build compressors for all of these different models. So it's just a plug-and-play solution. You just, instead of sending your input directly to the big models, you send it to us first, and then you send the compressed input to the big models. It's really that simple. Oh, now the scary bit. All right. Sorry. Sorry, guys. Okay. So this is our website, sqwish.ai, Sqwish with a W. You can go and try this out right now, but I'm going to show you an example of what we do. And this is our playground, right? And so we're going to look at an example where you have this Wikipedia article on coffee, right? So this is the Wikipedia article. And you have to answer a very simple question based on this, right? So during the age of sail, what unusual substitute for coffee did British sailors make, right? Let's find out. So this is the original input. So the question with the whole article. And this is the squished input. And this is Sqwish working at a very low aggressiveness setting. We can be absolutely much more brutal to these inputs, but we have already reduced 66% of input tokens. And you can compare and see that all of the information that was in the original prompt has been retained. We didn't really kick anything out, but we preserved everything that was necessary to respond to the question and more, right? And you can now compare the responses to both the original prompt and the compressed prompt, and you can see that they're pretty much identical. And it turns out that they had this disgusting tasting burnt bread in hot water as a substitute for coffee. So yeah, so that's what we do. So we ensured through our training that the compressed prompt doesn't lose anything in response quality. So you don't compromise on the responses, but you save in costs and time. Okay. I think that's all right. Sorry. So yeah, so how does this work, right? So we are basically training very tiny language models. So OpenAI's models or Anthropic's models are huge, and we train very, very tiny models to make these responses very fast. You saw in the demo it took like 200 milliseconds for Sqwish to process that output, right? And we need that to process these things in real time. And the models are very tiny, but they're trained on huge data sets. So we are training on very diverse data sets to make sure that no matter what use case you have, we protect all of the important stuff. We don't get rid of important jargon, numbers, tables, structure, all of the things that are important for having a high quality response. And we also use reinforcement learning to teach the model what to do and what not to do. And what we're better at than anything else that's out there is preserving this response quality, because that is our North Star metric. All right, so we do have some competitors, but yeah, these are mostly research prototypes from like Microsoft Research in Asia, and this is from a group in China. And the problem, so we tried these, we were facing this problem in our own work, and we tried these, and we found that these were trained on very narrow data sets, like meeting transcripts. And if you went outside that narrow domain, they were really unreliable, and they mangled your prompt. If you have code, if you have other things, they completely mangled it, and it was unreliable. And it is also only works for text, whereas we have plans to expand to audio and video as well, because those are emerging modalities in which people are developing apps with. So what have we done so far? So we have started this 3 months ago, and in the last 3 months we have trained a prototype. You saw the website, and the API playground is now live at sqwish.ai. Please go and try it out if you're interested. We now have 5 pilot partners. This slide is slightly outdated because we're doing a lot of customer calls and conversations right now. And the next milestones are to do the alpha rollout in 1 month, and then train the actual, from the prototype version to the actual solid production-ready version that we're going to roll out in about 3 months. So the long-term vision is that the recipe that we have for training this prompt compressor, of training these very tiny models on huge, infinite amounts of very task-specific data, we want to use that and expand to an ecosystem of specialized tiny models. So tiny models for specialized tasks in your AI workflow. So we see a future for AI where very big, bloated generalist models, like OpenAI's models, work with very tiny, very fast models for the low complexity tasks in the workflow, right? These could be things like prompt optimization, routing your query to the correct model, depending on how complex it is, or what the content is, extracting structured data from documents, cleaning up prompts. Sometimes people inject attacks and things into prompts, which you want to clean out, detecting AI content, building guardrails, for content safety. So all of these things can be done by very tiny and very fast models, and we want to build out an ecosystem of these models by using the same recipe that we use for Sqwish, the prompt compressor. And this is the dream team. That's Federica over there with the gimbal. We have known each other since 2018. We met in Cambridge. I was doing my PhD. She was graduating with her master's. Both of us have a ton of experience working in AI. So between the two of us, I think we have published between 25 papers in machine learning and AI. And we have also been colleagues in a top Fortune 500 research lab called MediaTek Research, where we worked as AI research scientists. And we worked on optimizing the very same problems that we're working on now, building apps on top of generative AI, training foundation models, optimizing models for performance. And that experience actually informed Sqwish. And we also had a startup together. We were building AI workflows for creativity. And we found out that we were feeding large amounts of information, web pages, research into this brainstorming workflow, and we were having that same problem, waiting for infinite amounts of time for responses. Costs are mounting as a tiny startup. And that really motivated us to pivot into this solution that we thought could help many more people than maybe a brainstorming workflow could, which is why we're so excited to work on this. And that's pretty much it from me. And what we're really looking for is feedback on the website that you just saw. If you can go and if you can tell us if there is something that we're not communicating correctly. And we're also currently looking for design partners. If you are building, if you know somebody who's building AI SaaS apps or have workflows with very long inputs and they want to optimize their AI workflows, please ask them to get in touch with us. That would be so helpful. Thank you so much.
So any questions for Ushnish?
Looks very impressive. I really appreciate the focus on diversity of data. It's such a huge pitfall when you do these LLMs. You start working on something, it looks great, and you go and ship, and then you come up with just an amazing amount of edge cases in ways which doesn't work. But my question to you as a fellow entrepreneur is, how did you get those 3 to 4, 5 pilot customers? It's very impressive in a short amount of time.
So what we're doing is like a combination of warm outreach. So we have, thank you. So we have had some very helpful mentors. So we're part of Accelerate Cambridge, which is this startup accelerator, and some of our mentors have been extremely helpful in introducing us to potential customers that they know, because our network is not that wide. But also, we have been, doing some sneaky underhanded things like, we found out who was interested in like that research prototype that we talked about that doesn't work very well, and we found out who started them on GitHub, and we just did some cold outreach to those people. And we also looked at customers of some other companies that are kind of solving the same pain point of AI efficiency, making things faster. And we are just doing some cold outreach. It's very brutal. It's 1% or 2% of people get back to you, and even fewer convert. But it is a learning experience, and it's hard. It's hard trying to get those early customers.
Anyone else? Yeah, we'll move the microphone around.
Thank you. Hi, that was a great pitch. I'm just, from a technical point of view, interested in how you see the company evolving, potentially in a world where transformers are no longer the dominant paradigm for large language models, because the latency issues you describe are ones that I deal with all the time, in a slightly different context. But the main issue there, as I see it, is just a consequence of how poorly transformers scale within the context length. And there's a large body of work already going on to try and find the successor to the transformer that has more favorable scaling behavior. How do you see? I guess I'm just saying, if something other than a transformer comes to dominate, do you see a way forward?
So that's a very good point with the latency. I think there are definitely new Mamba and other architectures that are coming up, right? We are very mindful of that. The nice thing about that, in the Mamba, people still charge per token, right? So the business model is still the same, so the cost pain point is still there, with very large inputs especially. So that's, I think, prompt compression, even in a post-transformers world, will remain relevant, but I think the pain will be reduced if the latency really comes down significantly, right? So we do agree. But also, I think, again, which is why we have this idea of building an ecosystem of tiny, fast models, right? So the same idea of just, train a very tiny model, but just generate a huge data set that is very task specific, and then use reinforcement learning and all of these little tricks that we have, and very granular metrics. So that is something that is very general. I don't think tiny, fast models are going away. Prompt compression might become less urgent, as you say, with new architectures, or with new GPUs or new hardware. But I think tiny, fast models are definitely not going away. We do see that being very relevant. Big models working with tiny models is like a paradigm, I think, that we are going to go into once companies start focusing on efficiency rather than just prototyping.
There's somebody at the back there. Sorry. Thank you.
Yeah, great pitch. I feel like I'm in an episode of Silicon Valley, which I think is the kind of the topic of the first episode of compression techniques.
We also got our IP stolen.
No, really good, and I really like the vision as well. I think the question I have is just on the stats around what you lose in terms of quality.
Yeah.
Just some feedback. That was immediately my question was, okay, you tell me it's better than everything else, but having run an AI company for many years, we always had this trade-off between accuracy and speed, and accuracy always won out. And so I think having some sort of proper data around that is going to be really important for you. One more.
Yes, really nice pitch. One of the things which I personally feel like this could be a use case for this particular product is like RAG, for retrieval image generation, for RAG chatbots, because many companies are trying to work on with Flowise, different platforms. If this could squeeze the input and tokenize that could really transform the RAG industry as well. So are you thinking of probably providing some sort of chat building interface with embeddings for working with large documents, something like that, or a retrieval-based, recommendation generation-based chatbot, something like that?
with regard to the question about the benchmarks, we definitely do agree that we need to have. So that 14% improvement that we talked about, of course, that is for a very specific benchmark for actually RAG, interestingly, and with very long inputs. So we definitely need to run very rigorous tests and evals to convince people that you don't really lose that much and sometimes you actually gain. We definitely agree that we need to have. We will have a very comprehensive suite of evals and publish them on the website in an open way. So we will definitely be doing that. And as for RAG, yes, I mean, some of our early pilots are actually doing RAG. And yeah, so the question then is that how deeply, like what kind of solution do we want to offer? Do we just offer the Sqwish API, or do we offer like RAG with Sqwish, built in? It's a difficult question. I mean, I would maybe at this point prefer to like give people tutorials on how they could integrate Sqwish into their existing RAG workflows, rather than trying to offer a RAG solution, because then we're competing with RAG providers, and yeah, they're quite big. But it is an interesting question, and one that we are definitely thinking very carefully about. Yeah.
Cool. So thanks, Ushnish. Fantastic presentation. So our next presentation comes from Yunpeng Li. Yunpeng is a leader in AI and digital and oral health at King's College London, and CEO of Be Certain, which is the company we're going to hear about. He's a computer scientist specializing in statistical machine learning and based at King's Dental Faculty. Has a particular interest and focus in developing novel AI solutions for dental and oral health problems. So the work here has been sponsored by the NIHR, EPSRC, NERC, Royal Academy of Engineering, Research England, and Industry. So, Yunpeng, your mic.
Thank you very much, Mark. Hi everyone, my name is Yunpeng Li. So as Mark just introduced, so I'm a computer scientist. How did I end up as an academic in the UK's top dental school, and also CEO of Be Certain, or spin out to in the field of dental AI? Well, it all started in my second visit to the UK dentist. So back in 2019, so I moved to Guildford as a lecturer in AI. And one of the first things you do when you move to a new place is to find a dentist. I found it's very hard to find an NHS dentist, so I decided to go private. And my dentist, Dr. Jonathan Tan, has a very good review. He spent 3 minutes to finish my routine dental scaling and charged me for £78. I think that he needed to justify the £78 he charged me. So he started to talk about the pain point in dentistry. That is, according to him, that dentists make a lot of error when they look at the dental x-ray. So when you first have that routine dental x-ray examination. So I said, thank you for charging me for £78 and now telling me you are half guessing. Dentists are often quite chatty, and he knows that I'm working on AI, so he asked, can we have a mobile app that he can open the mobile application, and then the mobile app can use the camera to look at the x-ray and then tell the dentist where are the diseases and what are the diseases. And that is what we have launched earlier this year. To me, this is a fascinating machine learning question, because this is not a standard machine learning problem. The reason is exactly because of the pain point in dentistry, that dentists make lots of errors. For example, look at this dental x-ray. So I don't pretend that I know where the disease is, but I will invite you to look at this dental x-ray and tell what are the diseases and where are the diseases. Just to save everyone's time, so I have asked 5 dentists in the Guy's Hospital, so the top dental hospital in the UK, ask people the opinion. So those are specialists, dentists. Look at the same x-ray. Some say this is a healthy dental x-ray, some say there are lots of bone loss and dental caries, and some talk about something else. And that is the question that we are facing here. The problem here is that you can often not have a yes or no answer to a dental x-ray. So this is a 3-dimensional object, sometimes can be very subtle, and then dental x-ray is just a 2-dimensional average, 2-dimensional projection of this the disease. So it can always be difficult to tell. So the machine learning solution need to be able to recognize the challenge here in the training. And this is not a small issue. So 50% of misdiagnosis of dental disease, as I just talked about, and also in the UK, half of the medical images are dental X-rays, so 20 million X-rays per year, and that is a big problem. So in the abstract level, I'm a machine learning and scientist. I like to think about this in a more general sense. This is essentially the decision combination. How can we combine inconsistent and also imprecise decision from multiple people and help us train a better AI model? So the challenge here that we are facing is that people often have different opinions and different reliabilities. And then in terms of medical images, so what we often do is to have a panel, expert panel, to form consensus. But you know this is very time-consuming and challenging. For example, right now we are recruiting dentists to annotate dental X-rays, so 100 pounds per hour. So if we recruit 5 dentists sitting together and looking at the X-rays slowly, that's going to be very costly. So for a machine learning problem, our goal is to how to increase the AI model accuracy by automatically learning the reliability of the annotator and help us train a better AI model. And that is essentially what we are doing in this NIHR sponsored project to develop a UK-based technology on dental AI. So you may have heard of, there are some existing products in the UK market, mostly from US. And the issue here that when I look at their results, there's a claim of accuracy, and you never find the reports, or let's say so basically you never find the large validation study and also results to show what is the accuracy that they claim. So we want to be more transparent here to have statistic powered clinical validation here. But also, one of the key issues that we want to address is this trustworthy AI model. So there can be 2 parts. First, the AI model confidence. Clinicians cannot have the certainty of the diagnosis, so neither does AI model should have that. So how can we train the AI model to tell the AI model confidence and also tell the reliability of different annotators? And also, trustworthy AI model is also about the expert dental X-ray annotation. So essentially, we are really recruiting the dental specialists to train the AI model, but we found that there are often crowdsourced annotations that you shouldn't really rely on. And also, trustworthy AI model also comes into the domain expertise. So the annotation and also in building the AI model. So when we build the AI model, it shouldn't be a black box. There should be the guard, so safeguard from the dental expertise. So that is why we have the rules, domain expertise embedded into the AI model. That just gives us more confidence, and also by the users. And also usability study and cost study are also the components included in this product to develop a regulated medical device here. So in my view, trustworthy dental AI includes fully protected patient data. This looks so obvious, but when you look at the available market products, they actually most of them require you to not just upload the images, but also patient information. And actually they store it. For us, when we collect all of the dental images, we anonymize the images, so we don't have let's say the patient ID and also patient name there. So we have to create some random name there, and one day we got a call from a company that built a competitor product asking why your patient name is all wrong. So not only they have AI model look at your data, but also have real human look at that. So in our product, we do not store any image and also metadata. And also meaningful model confidence, uncertainty, ambiguous case, and also AI plus domain knowledge. So that is what we have here. And also this is a comparison with competitors. We haven't raised any equity funding, so we have general research funding from the UK government. And look at the competitors, so lots of investment, so different stage. We have the only model here, so pioneering the trustworthy AI model with calibrated uncertainty. And also strict data protection, remove the data after the session, and also statistic power independent study that we will basically quickly do early next year. So here we have launched our MVP, this BCertain.ai. So essentially, our model can detect 11 pathologies and non-pathologies, including those subclasses. So we can actually detect 20 different classes. So that's more than most of the, actually all of the competitors. So caries and bone loss, so 4 or 5 different stages, and also periodical radiolucency calculus. And also you can detect or segment the tooth anatomy and also the automatic generate dental reports. So we work very closely with dentists. So for example, they say, one of the things that they found very useful is that they don't have time to write medical legally compliant dental reports. And they are under huge pressure. If you look at NHS dentists, they are seeing around 30 patients per day, 15 minutes per patient. They really don't have time to do this. So such a tool is directly from their feedback. They say, can we have a copy button, and they can copy and put into their note? So that is what we have here. And all you need are 3 clicks to get your results. So you have the X-ray shown on the screen with any X-ray viewer, and then you open our initial, let's say, this MVP. So it's a desktop version, but also I'm going to show a web version, so you can access it from anywhere. You click this capture button, and it can basically open, so like a zoom function, and it can open all of the windows screen on your computer, and then you just find that window with X-ray to automatically find the X-ray shown on the screen, and click this inference. You will get the results. So you can get the disease detection results, segmentation, tooth number, and also the dental reports. I'm going to show the demo, so everyone can see it.
Be quick.
Yeah.
Close to time.
Sure. Well, this one already found it, but I'm going to yes. Basically, just now I have done, let's say, just a search called bite when radiograph. So I'm going to open this DS viewer and just find this page. And it will basically look at the X-ray, and you can also adjust if you find that you want to adjust the region, and automatically you can get the dental X-ray segmentation tooth number. And that's what I learned from this project. So every tooth has a number, and then also this report that you can copy and close. So I'm going to go back here. Yeah, well, how can I go back to the, let's see.
But you won't go back to your deck.
Okay, no, I think right now should be fine. So looking at the opportunity, I'm going to be quick. So again, lots of big numbers here. Right now, initially we're targeting the UK market, and to do that, fantastic team. So Owen Addison is the head of Center for Oral Clinical Translation Study. Quite interesting, 3 years ago I received an email from him. So he saw my advertisement of a postdoc working on this, and then he said, your solution is just makes so much more sense because you are looking at the uncertainty. And then we become a collaborator, and right now, fantastic collaborator as a chief medical officer in this project. And he actually successfully moved not just me, but my whole team from Surrey to King's, so based in the largest dental school in the UK. And CTO Yunpeng Li, serial entrepreneur, top coder, very good machine learning researcher. I think right now over 18,000 citations about his work, and then really help us building the MVP very quickly. And then Alex is our entrepreneur lead in the iCure program, and Jimmy Makisi is the founder of GM Radiology, the country's largest dental X-ray consulting firm. So basically, yes, it's the CBCT consulting firm. We're really lucky to have Mark as an advisor, and also Mark Holland-Brown. So he's head of scientific computing at Royal Surrey, and also a top regulatory compliance expert. And where we are, so we have good research progress and also right now commercial support. So right now we are raising the pre-seed fund, mostly on the R&D team and business team development, and also regulatory compliance. So if you are interested in help us in those different aspects, I look forward to chat with you. And that's all. Thank you very much.
very much, Yunpeng. Do we have maybe one question or two at a pinch? Anyone with a question for Yunpeng?
Hi, first thanks for the great presentation. I'm just interested in how exactly you're different from your competitors. I know you mentioned it, someone like say a Vidya Health or a Promaton. What makes you different? What's unique here?
Yeah, so that's for the question. Good question. So our USP is that our model's ability to recognize the data annotations, different reliability or unreliability from the different annotator, and also express the model's uncertainty. So if you use the off-the-shelf object detection or machine learning model, you essentially recognize all of the annotation are ground truths. And we saw example, they are not ground truths. And for example, if you are using YOLO, it's fine with autonomous driving, no, that is definitely a car, that is a bike. But here, that is not. So what we do is that we can automatically learn for each annotator, each dentist, what is the confusion matrix. So for different diseases, so 20 different types of diseases, so what is the accuracy and false positive, false negative rate of those annotators, and use that information to help us train a better model, and that is automatically done. And after that, the model can also tell the model confidence. So if our model says that it's 60% confident, it just is aligned with 60% of dentists. When they look at this area, we agree there's caries or bone loss there. So we have that capability there, and also it's patent protected technology.
Thank you very much. So we're a bit short of time, so I'm just going to press on if that's okay, and maybe you can catch up with Yunpeng with any further questions at the end there. So our final presenter this evening, there's a pattern because I'm also involved with Grounded AI as well, so apologies for my self-dealing in this. My colleague Nick Morley is going to show some work we've been working on at Grounded AI. Nick's background is in neuroscience. He's worked in his career in that area and working in the area of sorry, I'm just looking at my notes here.
He's only been working with me for a few years.
Exactly. His working career has been in life sciences. He's an engineer and machine learning practitioner. And Grounded AI as a business has been for a while now building solutions, looking at verification, and that's what we're going to be talking about tonight. So thanks very much.
Thanks, Mark. Thanks to my previous speakers, very inspiring talks. Some interesting parallels as well. So Yunpeng just mentioned in a snippet there some claims being made in some reports about accuracy, and those claims maybe not being easily and clearly supported. So that's actually going to be a real focus of our talk here. So I'm going to be talking about Veracity, which is our tool for citation checking. So it checks content for citation inaccuracies and patterns related to citation misconduct. So I'm going to talk about what that means, why there's a demand for it, and of course I'm going to demo our solution. So what is the problem? So the scientific publishing industry is currently having huge challenges in maintaining content quality and integrity. So the numbers around this vary a lot, but the current estimates are really quite shocking. So you've got estimates around really high proportion of citations in the scientific literature being problematic in some way. So what does problematic mean? Well, I'm going to go into more detail about that. But one thing to note here is that these things are on the rise. So these numbers are going up all the time, and there's every reason to expect with the growing use of AI that they're going to continue to go up. So frontier models like ChatGPT, they demonstrate this really high tendency of what we'll call hallucination or fabrication. So that is absolutely no exception when it comes to citations. So they have been well studied that they make up citations entirely, or they will use them in subtly incorrect ways. So we're going to see some examples of that as well. So, who does it impact? Who needs solutions for citation checking, and what is the market for this? So, first and foremost, we're focused on three customer segments. So, first and foremost, publishers of scholarly content. So, the situation there is that there's a hugely increasing number of articles being submitted for publication every year. So we're now currently up to about 20 million submissions going through the system every year, and that is received and published and reviewed by about 50,000 journals. And these journals are managed typically by publishers, so you'll have heard of people probably like Elsevier, Springer Nature, Wiley, and down the road you have Cambridge University Press. So these are publishers. And every one of these submissions, they have to be extensively reviewed. So peer review is this traditional sort of gatekeeping mechanism for maintaining high quality. But the thing is, there's such a high volume of content flowing through the system right now that the reality is that stuff gets through. So there's a lot of errors which go under the radar and they end up getting published. And in particular, citation-related errors, because citations are these things where you get a report, it's filled with references, could be 50 or 100 or 200, and to check all of those is an extremely laborious process, and the reality is there's just not enough time for peer reviewers and editors to thoroughly check those. So some ends up getting published, and ultimately there's a lot of error which gets through, and this is reflected now in the rising rate of which papers are being retracted from the literature. So the result of this is damaged reputation of journals and authors, and ultimately that leads to revenue loss for those publishers. So there's a big opportunity to assist editors and peer reviewers within academic journals with tools that can help them manage that workload, to help them review content, make sure it's of the utmost quality. So the second opportunity is with institutions. So this is like research organisations and universities, and these are the organisations which are actually putting out research in the form of papers and articles and reports. And for them as well, putting out the quality, the highest quality and quantity of papers is really important, because that's what essentially dictates their rankings, it dictates their ability to attract talent and get funding. So existential threat if you end up publishing stuff which has got a lot of errors or is associated with any kind of scandal. So there's a real emphasis on this right now to maintain this high quality, and that's reflected now by the fact that you actually have these dedicated job roles in institutions for this. So you have integrity officers now who they're part of institutions but also publishers. And their job is to basically make sure that everything that leaves the door, to be published is of the utmost quality and integrity. So the opportunity there is to provide tools to those integrity officers, those teams, and people within that organisation, help them maintain the highest quality. So third opportunity is to go directly to the authors. So these are the individuals who are actually writing research, and they are under a huge amount of pressure. Their career advancement is dependent upon publishing a really high volume of high quality papers. So anything that can help them do their best work faster and make sure that their work is as validated as it can possibly be, that's going to be interesting. So you can think about that like Grammarly for citations. So those are the customers that we are focused on. So we're all familiar with this practice of citation, right? It's this backing up claims with references. So what does it actually mean to make a citation inaccuracy, or what is citation misconduct? Basically, how many ways are there to get it wrong? Well, there are lots of ways to get it wrong, and I've tried to chart out the different categories and cases of citation error that we see and try to detect every day with our tools. So you may not be able to read all of these, and I hope you appreciate the colours, because I'm really quite pleased with this. So I'm just going to go through some of these categories. So one way to get it wrong is to there's this notion of bias and overrepresentation, right? So you can overly cite certain entities, such as you can overly cite yourself, you can overly cite certain other authors who you work closely with, and this is called a citation ring. You can overly cite certain affiliations and things or entities you're associated with. Now, that may be fine, that is fine to an extent, but also if you're doing that at the expense of including better, more relevant evidence, that's something which editors of journals are very interested in being able to detect, right? So another way you can get it wrong is to cite sources of low or questionable quality. So if you cite something which has already been retracted, that's a very known credibility issue, you're going to want to flag that up. You could cite journals which are of a lower standard than the journal you're trying to publish in, would accept. So there are various different levels to measure there. Another way of getting it wrong is to actually not include sufficient citations. So you need to include sufficient evidence to back up all of your claims. Are you using the best, most up-to-date evidence? Are you actually excluding any evidence that might, contradict your claims? So you're not cherry-picking the evidence. There's also this question of relevance and support. So do the citations you're referencing actually, truly, and strongly support what you're saying? And that may sound silly, but you'd be surprised at how commonly within the scientific literature you actually follow through a citation to its source, and you find that, hold on, I don't see how this actually supports what the author's saying. It's actually shockingly common. So it's a very interesting thing to be able to detect. Metadata, this is a humble case of, have you got the right author names? Have you got the right year? Have you got the right URL? The URL actually goes to the source that you mean and not something else. So there's a whole bunch of honest errors that happen there. And the final one I mentioned is fabrication. So as I alluded to at the beginning, if you're using AI to help generate papers, help you write papers, you better make sure that the sources you're citing are actually real. And now I'm going to actually show some examples of that, if I can do the kung fu of, I'll look at that. Excellent. Right. So this is the Veracity user interface. So it's quite simple. On the left you have the content, which we are checking. And on the right, you have the comments, which are automatically generated by our system. And you can see we've highlighted things in green that we've checked and found to be fine. And we've highlighted things in amber or red where we think there may be potential issues, or things that warrant attention. So, this content is ChatGPT generated content. So this is going to be a great example of some of the hallmarks of AI usage as it pertains to citations. So this is quite a modest error. So we've basically not been able to find TANs yet out of 2007. We can find one that's 2008. So it's an off by one error. This is very common in AI generated citations. It's also very common human error. So that's something we can detect. But something which is much more unique to AI, which is something you really want to avoid, which is a source which actually we can't resolve to any real existing paper. So you can look and look. So we're modest here. We're saying source not found, but the reality is more like you made this up. You don't want to be publishing that. So I'm going to get to my second example now. Now let's refresh our palette with a bit of human-generated content. This is published by our friend Will Fortin at our partners Hum. So Hum is a technology company operating in the scholarly publishing space, and he wrote this paper. It's a great paper. This is pre-peer review, so there are some errors that we want to pick up here. So the first thing is simple case of a URL that is provided in the bibliography that doesn't seem to go to any. It's a broken link. The website is down. So he could have, that could have gone down after he made his bibliography. So that's fine. It's very easy to miss. Something we can pick up very easily with automation. I want to get down here to something which is a lot more nuanced. One of my favorite examples. So what's going on here is he's making a claim and he's including a piece of numerical data. So he's saying 0.03 degrees, blah. Then he's citing two papers. So
you'd expect to go to those papers and find essentially that supporting number or maybe a range of numbers. You want to find that data. And so our system has gone to that first paper and we've been able to find that reference to exactly 0.03 degrees. And this is great, provides a little summary for me here. So as a peer reviewer, I can see, right, that's how it's supporting it, that's how it's relevant. I can go and dig into that if I want to, but okay. Now, what about this one? This one's in amber, so why? So this is the opposite case. We've actually not been able to find that piece of numeric data. So that's interesting. Now, this is a subtle case because this paper is topically relevant, and the author has great reasons for citing this, but this is something that we can flag up to stimulate this conversation now between the author and the peer reviewer. So this is something I'm going to want to get some feedback from the author from. Is that time already, Mark? All right. Now I've got a lovely outro, but I'm not going to show it because I'm out of time. So that's the end of my demo. Citation is important. That's the short version.
Thank you so much. I think it's very, very important and relevant. I think I'm just curious, how do you have access to all the papers, all the scientific literature out there, which is behind paywall for most of us?
So we don't. And that is part of the challenge. Now what's interesting is peer reviewers, they often don't either. There is a lot of the time they don't have access to the content they actually need to validate the work they're reading. It's incredible. Now we do have access to all of the public data, so abstracts. Now there's always so far you can go. With abstracts, sometimes you can see the relevance just from the title. But from that example of the numerical data, you do have to go into the full text. So we're currently working with the publishers we're working with. So I just mentioned we are actually partnered with some large commercial publishers to pilot this stuff basically. And so we have access to their corpora of full text, and that's something that's a problem that actually the whole industry needs to solve. But yes, it is a challenge that we work with what we've got.
Anyone else? Does anyone want to see Nick's outro?
Yeah. Okay. Yes, so to re-emphasize, citation is fundamental to scientific progress. It is absolutely core to how we build upon information, how we share information, and how we decide who to reward for that information. And so fields of science and law are actually entirely constructed around the practice of citation. So we've got to get it right. And these fields are currently under threat with a declining quality of information. So we need tools to help maintain the highest standard of quality and integrity in our information space. And that's our goal with Veracity. So, yeah, I've mentioned the piloting, but I've mentioned it. So.
Fantastic. Thanks. That was a peroration. Thanks very much, Nick. And thanks very much, everybody, for coming. There'll be drinks and I think pizzas next door. So thank you very much, everybody. The next event will be on the 23rd of January when we will be talking about the sort of hacky guides to using Gen AI to make your life better in a number of different work contexts. So marketing, managing an engineering team, different areas. So that's the next meeting after Christmas. But in the meantime, thanks very much for coming and see you next time.
Thanks.